Okay, these questions are great, I think. So I've got a pot of paint and I've got a half an amount of paint. So I'm going to actually draw them separately. And altogether, this is 5.8. And then I've got my pot of paint and then a quarter of it is full. And that gives me 3.1. Now I'm going to do this without algebra to start with. If I was to subtract these, then I would be left, I would basically, subtract this and this and this and this, and I'd be left with a quarter of the paint. And that would be 2.7. So if I want all of the paint, then it would be 2.7 times 4. I can double it to give 5.4, double it again, 10.8. And also I can work out the weight of the pot because if this is now 2.7 and the whole thing is 3.1, then the pot must be 0.4. And I could even check it over here because half the paint must be 5.4. And then again, I can see that it's 0.4. So what is the weight of the full pot? It's going to be 10.8 plus 0.4. It's going to be 11.2 kilograms. Well, actually, I think that's the best way of doing this question. I've not needed to bring an algebra. I've just used, just drawn some pictures and thought about subtracting and so on. But let me show you how you could do it with algebra. So we've got the weight of the pot. Actually, what should I call? I'll call it X because I'm going to call the paint P. So the weight of the pot plus half the weight of the paint is equal to 5.8. And then the weight of the pot plus a quarter of the paint is equal to 3.1. And now we've got simultaneous equations to solve, but we can in fact subtract these two. Okay, this is assuming that you've covered simultaneous equations, which you might not have, in which case the first method is the way to go. But having said that, hopefully I can make it make sense. I'm basically, I've got two equations, and so if I subtract one equation from another, it must be that I still get an equation that works. It's a bit like when you got a set of scales. If you were to have two sets of scales balanced, but different weights, if you then combine them, like put this and this together and this together, it must be that your overall set of scales is still balanced. It's the same idea here, but I'm subtracting them. Because the reason I'm subtracting them is that these then cancel. And I'm left with a half p is equal to 2.7. So this is exactly the same as what I did. Oh, sorry, not a half p, a quarter. My mistake. A half p minus a quarter p is going to be a quarter p. This is exactly what I did over here. Okay, I just didn't write it down algebraically. I can then work out that P is going to be 10.4 and substitute in to work out X. It's just a slightly different route. It's good to see both.